Hello, so in this video I'm going to talk about basic trigonometry, what it is, how it's used and how you can solve problems with it. So, first things first, what is trig? So trigonometry describes a relationship between the sides and angles of right-angled triangles. So for first I'm just going to show you a triangle. Just not a right angle triangle, just any random triangle. Look at this angle here. So we use theta to denote angles. They are, it's a Greek letter. I don't know, mathematicians like to use them. God knows why. So you can see, look at the angle opposite theta. If theta is bigger, if it's a larger angle, then the side opposite it is going to be bigger. But then also at the same time, if it's smaller, is that going to fit? Yeah. Then the side opposite it is also going to be smaller. So what I've just shown there is that there is a relationship between the sides and angles in a triangle. Of course, that's the same in all of these triangles for this angle and this side, that angle and that side, and then of course this angle and that side, and that's true in all three of the triangles. Okay, so what trigonometry basically does, at least at this basic level, it allows you to use that fact to be able to calculate the sides or the angles. Okay, so first you have to know what we call the sides and angles. So you'll pick your angle theta, the angle you're interested in. Yet note that these only work in right angle triangles. This is just the way to do with how the ratios are defined. You don't really need to know that at this level, but that is why. You call this the hypotenuse. This is the adjacent. And this is the opposite. Yeah, adjacent is basically just math speak for next to, opposite. It's quite obvious. Opposite the angle, next to the angle. Then the hypotenuse is always going to be the largest side in the right angle triangle, and it's always going to be opposite the 90 degrees, so the actual right angle. So the reason why that is because obviously it's the largest angle. It's got to be the largest angle by just definition, because the angles in a right angle triangle add up to 180, and a right angle triangle is 90 degrees. So 90 plus, it must be like 89 plus 1 equals 180. Those are the other angles. Okay, so now the trigonometric ratios relate the angle to these sides. And what we use to remember this is SOHCAHTOA. I put the dash in here to make it easy to remember what this means. So what this means is the sine of theta equals opposite over hypotenuse. The cosine of theta equals the adjacent over hypotenuse. And the tangent equals theta. Tangent of theta equals O opposite over adjacent. Okay, so all of these trigonometric ratios work exactly the same in equations, that is, which you need to set up using these three formulas. Now you need to decide when you've got a question which one you're going to use, because in a SOHCAHTOA problem, you're going to have two sides you're interested in and a angle. For example, let's say you're given this triangle here. We're going to call this 8 and we're going to call this x. Let's say theta is 30. Okay. So which trigonometric ratio are we going to use? Because we've got two sides and a angle, so yeah, we're going to use SOHCAHTOA, but then which ones do we have? So that's going to be the hypotenuse because it's opposite the right angle, and this is opposite the angle, so we've got O and H. So going back to trigonometric ratios, which one do we use? O and H. We use sine. Okay, so we know our angle is 30. So sine of 30 equals the opposite, 8 over x. Okay, so here we just treat this as a normal equation, just you're trying to get x by itself. How do we do that? X equals 8 over sine 30. You can see how we've just times up by the x and divided down by sine 30. So now you plug this into your calculator. Make sure that your calculator is in degrees and not radians, because that's so easy to lose marks on. It's just something you don't really want to do. So you do 8 divided by sine 30 and you get x equals 16. Now another example, let's say, is when you have other sides. So let's say you're given this, you're given theta is 53, this is x this time, this is going to be, let's go for 23. Yeah? What do you have now? Okay, so, and that's your, yeah, so we've got the adjacent because it's next to it, and this is the opposite because it's opposite it. So which one are we going to use? Tangent, because, you know. So we're saying that the tangent of 53 equals x over 23. Okay, so how do we get x by itself here? You just times up by 23. 23 tan 53, tan of 53 equals x. Okay, so then you plug that into your calculator and you get x equals 30.52 to 2 decimal places. So these SOHCAHTOA problems, 30 is a special number in this because, well, I'll tell you later why. But most questions you're going to get really nasty numbers like this, 30.52, and it will tell you how many decimal places to put in. So you should be fine, but yeah, it's just not nice to work with nasty numbers. So what if it's the other way around? What if you're given two sides, but you want to figure out how to find, you want to figure out, yeah, oh my god, that is awful. Yeah, you want to figure out how to find an angle. You want to figure what is going on. Okay, so you've got this, you've got your opposite, you've got your adjacent, and the hypotenuse. You know that sine theta equals opposite over hypotenuse. But how do you use theta? Could you just go like theta equals O over sine h? Could you just divide by sine? No, because sine is, it's not that you're multiplying sine with theta. It's something called a function. It's acting on theta. So the only way you can get theta out of that function is by using something that counteracts that function. So it's called the inverse function. How many times can I say function in one sentence? You tell me. So this is what it is. So you apply the inverse function to both sides. Now, of course, on this side, it's just going to cancel out. And this ends up just being a value. That's your answer. A few things to say about the inverse function is that actually it says sine to the -1, but that's not really what's happening. Because -1, you usually think, if you're given, let's say, 2 to the -1, you say that's 1 over 2. Sine to the -1 is not 1 over sine theta. This is just really bad notation. It has since been fixed, but you won't see it on your calculator. People call it arc sine of theta, but you just won't see that on your calculator. And to get this on your calculator, you need to press the shift button and then press the sine button. You should see that there. Cool. Now for an example. Cool. So let's say we've got our triangle here. Let me draw it. Okay, so this is your right angle. This is what we're going to call theta. And we've got 8 and 3. Okay. So what sides have we got? That's where you've got to start. What sides do you have? So this is the hypotenuse and this is the opposite. We're going to be using sine again. So sine theta equals 3 over 8. How do we get theta out of that? We apply the inverse function to both sides. Sine to the -1, arc sine, 3 over 8. So inverse sine, and how do we get that? We press the shift button. Sine 3 over 8 equals, so now here we get theta equals 22.02 to 2 decimal places. Okay. So you can see, intuitively that it's going to be quite a small angle, just because, okay, so we're like 8 meters away, quite a small side opposite. It's going to be quite a small angle. So that's just a little way to check if you're going to be right, because, these diagrams aren't going to be drawn to scale, but they're going to be quite accurate. You're not going to be able to get your protractor and measure it, but it's not going to give you something like 3, 8, where they're near enough equal. Stuff like that is just not going to happen. It can, but most of the time it's not, so you can just check kind of intuitively like that. Okay, so the last thing you really have to know for trigonometry is exact values. So let's say you've got sine theta, cos theta, and tan theta. That's going to have an exact value at 0. These are degrees, not forget that. 45 degrees, 60 degrees, and 90 degrees. The way I do this is set it out in the table, kind of like this, and then I would literally only remember the sine values. So sine theta at 0 equals 0, then it equals a half, then it equals root 2 over 2, root 3 over 2, and 1. So there is a pattern to this, I promise you. Okay, so first imagine 0 over 2, then it's root 1 over 2, but root of 1 is just 1, then it's root 2 over 2, then root 3 over 2, then root 4 over 2. Of course, root 4 over 2 is just 2, 2 over 2 is just 1. Cos theta is literally the opposite, just the other way around. Then tan theta, this is a bit above basic trigonometry, but can't hurt. But tan theta you can figure out by doing sine theta over cos theta. You can just memorize these, or you can just memorize that and then work it out. So what would that be here? 0, root 3, 1, root 3 over 3. Ah. What do you do here? You can't divide by 0. That's just undefined. You just can't do it. Okay. So then let's take sine theta and let's plot that on a graph. So let's say this is theta and this is sine theta. What is the graph of sine theta? So we've just said basically it's gonna grow like this. It's only gonna go to 1. That's the maximum value it can be, and that's at 90 degrees. Okay, so throughout time it kind of produces this wave type pattern, and it goes down and back up, and then that's going to be at 180, 270, 360. The way I remember this is something interesting happens at every 90 degrees. So, and it's going to be symmetrical about this for this first 180 degrees portion. That it's going to be symmetrical. So let's say you have at 30 degrees, that's going to equal half. Then if you extrapolate that to the other side, and at 150 degrees, it's also going to be equal to half. Cool. Okay. And then this just repeats every 360 degrees. So it will just go on and on. That looks awful, but on and on and on and on. Okay. So then what about cos? That basically works the exact same. Something interesting happens every 90 degrees. However, this time you start at 1. The graphs look identical, they're just a shift, a translation of each other. That's it. But then when you get to tangent, things change up a bit. What happens, well, you start here and you increase and increase and increase until eventually you just shoot off towards infinity. This is called an asymptote. Because when tangent equals 90, it will approach to infinity, but it will never get there. It isn't defined at 90. There is no value for it there because of the dividing by 0. But then it's the same as the other graphs, and it just repeats and backwards. Ignore that last one. So yeah, that is how this trigonometry works. If I were you, I would definitely remember these. This is this and SOHCAHTOA are the most important, because in SOHCAHTOA questions, often you'll get, for example, this one back here, 30. They'll be expecting you to see, oh, this is a SOHCAHTOA question with 30. I know the exact values. So let's do this question again, but knowing the exact values. So this is 30, this is x, and this is 8. So this could come up on a non-calculator is what I'm trying to say. Sine 30 equals opposite over hypotenuse, 8 over x. Now, am I tweaking? Yes, I am. What am I on about? Okay. Half equals 8 over x. X equals 16. That's just rearranging, dividing by 2, times by 2, times by x. That's just how you do that. So that could come up in a non-calc. So it is very important to learn these, and they can just ask you, what is sine 30? What is cos 60? And you just need to just relay that off. Okay, so in maths classrooms, and what people often wonder about mathematics is when am I ever going to use this in my life? The short answer is you're probably not going to, but it is useful. I'm going to prove that. Okay. So, let's say you've got 3 points. This is just of land. There's going to be some kind of distance between them. Yeah, and how else are you going to measure distances between places? Because, you know, you're not going to get a massive measuring tape between London and Birmingham, are you? You just can't do that. So you get 3 points, and you measure the angle between them. And you use a bit more advanced trigonometry, but it's still trigonometry, still sine, cos and tan, to figure out the distances between them. Okay, so you need it for making maps and how you do that. This is how the Ordnance Survey did it. It's called triangulation, and it's very useful. You know, physicists also use it in diffraction gratings and things like that. So physicists use it a lot, and obviously there's a lot of maths surrounding it, and trigonometry is quite basic at this level, but it gets a pain, and it's just, you need to have a thorough understanding of the basics. Okay, so I'm gonna link in this video and in my bio some PDFs, which they're just gonna be like a summary of the topic, not an in-depth explanation, but you know, you can catch up on them. You can read up just some notes before you go into an exam. And yeah, so thanks for listening.